Okay, in this example problem, I'll do problem number 5 from homework 2. And in problem 5, we're looking at taking some data from layer 4 and sending it down through layers 3 and 2. And here we're looking at the MAC layer header, the 802.3, that is the Ethernet. The problem says that header is 26 bytes long. In fact, it's 22 bytes long, and you can see that hopefully when you went back to the notes or anywhere to look at the 802.3 header, you could see that it was 7, 1, 6, 6, and 2, or 22 bytes long with a 4-byte frame check sequence at the end. And then holding data of up to 1500 bytes in length at the 802.3 MAC layer. And so in this problem we're asked to consider the use of the snap header, and let's see, the very next slide in the lectures talked about that and showed you this picture of the 802.3 header, which was 22 bytes long, then the LLC header, which was 3 bytes long, and finally the snap header, which is another 5 bytes long. And so in fact, as mentioned in the lecture, this data and pad here now is a maximum length of 1492 rather than 1500, because it's this 802.3 header starting here that can hold at most 1500 bytes. So we take 1500 and subtract these 8 from LLC and snap, and we get 1492. Okay, so that's what we're asked to look at here. And the first part says, considering the LLC and snap headers, what is the maximum length of IP packet payload that can be accommodated in this frame? Okay, so let's just look quickly. We've got our 802.3. That's the MAC layer. And inside of that we have the LLC. This is an 802.2, and then we have the snap header, and then we have the payload, and finally we have a 4-byte frame check sequence. Okay, and as I say, it is this payload here that is a maximum of 1500 bytes. But the MAC header is 22, LLC is 3, the snap header is 5, and therefore the maximum of the payload is 1492, which is the 1500 minus the 8. Okay, and then the frame check sequence was 4. And now it asks for part A, and this also gives us a layered model that looks something like this, where we have layer 4, we have IP at layer 3, and then layer 2 is kind of complicated because it has the snap layer, it has the LLC and the MAC, and then finally down here we have the physical layer. Okay, so layer 2 has all 3 of these pieces in it. Okay, so part A asks, considering the LLC and the snap, what is the maximum length of an IP packet payload that can be accommodated in this frame? So part A is the max IP packet payload length is 1500 minus 5 minus 3, or 1492 bytes long. Okay, and this payload, this is the layer 3 piece, and so that includes the layer 3 header as well. Part B asks, suppose the transport layer wishes to send 1,555,032 bytes using this network stack. How many IP packets will have to be sent? Well, the IP, so layer 4 sends 1555032 bytes. Okay, and so we want to find out how many IP packets. Okay, and well, what's happening is the maximum length of an IP packet is 1492. The IP header, if you go back to the notes and look anywhere, is 20 bytes long. So the maximum IP packet payload is 1492 minus 20, or 1472 bytes. Okay, and the IP packet payload is what is filled up by the data sent from layer 4. So the transport layer sends that many bytes to layer 3. So layer 4 transport sends that many bytes to IP. So that's going to be the IP packet payload. Is divided up into chunks of 1472. How many chunks? Well, the number of packets then is equal to this 1,555,032 divided by 1472. And that's going to come out with some decimal. Chances are it doesn't land exactly correctly. And so what we're going to do is we're going to round that upwards. And that's what these brackets mean. We're going to round that number upwards. And if you do the calculation, this comes out to be 1056.4 rounds up to 1057 packets. Okay, and I'm going to stop there for this video and continue on with part C in the next video.